All right. Hello. Good morning, everybody, or good afternoon, good evening, wherever you are. So welcome to the Rust Gamedev Meetup. So this is always an opportunity we've been holding for quite a while to have people come and show off what they've been working on over the past month. And so, and also to be specific, this is about the Rust programming language, not the Rust game. But we have quite a lot going on. Quite a few awesome speakers this month to show off what they've been doing. And as always, I'll push you towards checking out this month's Gamedev newsletter. We have just released it recently, and there's quite a lot in here to go check out. And so you can kind of see what games are being worked on, what game engine updates there are, what learning updates there are, and so on and so forth. And so always do feel free to take a look at that. Now, a little bit on my side of what I've been doing. I just wanted to briefly go over the stuff, some of the stuff I did last month. Oh gosh, there we go. So I was at Rust Nation in February. And so, wait, I think it was February. Yeah, it's March right now. So it was during February. And it was really cool because I was running a game jam there. We called it a micro jam because we wanted to design it for people to be able to come in and quickly make something, play around with some Rust game development, and then get back with what other stuff they were doing throughout the day for like the talks and everything. And so we ended up putting together like this small game engine. I talked about it briefly last month. And essentially what we tried to accomplish with it is making it easy enough for people to kind of come in, work on something for 20 to 30 minutes, and then be done. So it was a lot closer to a workshop. However, we did get some really cool stuff from people. And so I still need to go through and merge a lot of these games that people made as like demos sort of thing. But I do want to show off a quick video clip that I put together for the end of the day at Rust Nation, and kind of just show that was showing off what kind of stuff was going on. So I'll play that quickly here. Okay, I just realized that's like super duper loud. I don't know if there was like a way for me to turn that down. I don't know if it was as loud for other people as it was for me. What I'll do is I'll mute the audio and then I'll come back later and play that again. Okay, so essentially it was just like a demo of kind of the stuff going on. But that being said, I think we can hop over to today's audiences, today's presentations. And so we have 4 different speakers, which is pretty awesome. We have Elham here to speak about Blue Engine. Quark will be talking about Blade. We have 1000 Star talking about 8-bit duels, and then Keevan here, as always, to talk about graphite. So we will get started in just a second and be right back with Elham. All right, Elham. So I haven't heard about Blue Engine in a while, so I'm definitely excited to hear what kind of updates we have going on. So I'll hand it over to you.
Hello, everybody. Hello over to the YouTube too. This is Elham here. I've been in the Gamedev Meetup a few times, but it's been almost half a year since I haven't talked here. So I'm excited to share a lot of news about this because I've been going through some stuff in real life, like exams and stuff, so I wasn't able to keep up with the meetups. But let's get started about the Blue Engine. What is Blue Engine? Blue Engine is a graphics engine, first of all. The aim is to be easy, portable, and extendable. So what do I mean by this? By easy, I mean that you won't have to like pull your hair while working on it, so to speak. And it should be easier to use, just like every other engine in other language. But definitely the inspiration for the API and the easiness was the Raylib, because I was really impressed by how easy it was and how we didn't have anything similar to it in Rust at the time. So I've started working on this. By portable, I mean it should work on any platform that Rust supports. Right now, the platform support is still under work. We have mobile support, but uh, tests are needed because I don't have almost all devices in hand. But generally speaking, it works on all devices that Rust supports and the web GPU supports. Because we use web GPU standard, wherever the web GPU supports, we also support it. The code is also portable, so there's very little platform-specific code there. And we also have the extendable portion of the engine where you should be able to extend the engine however you want. So it shouldn't take your hands and like force you into a specific area, which is also a big part of what I'm working on right now, because we have a lot of things for it to be able to like fully work without needing a lot of modification on the source code. But that's all for the future, but and also for now. But let's get started on what happened on the Blue Engine since half a year ago. All right, so we have a lot of main changes on the engine. First of all, I want to note out that we have a lot of bug fixes done, because there was quite a few users of the engine, so the bug reports were very low. So we had to get a lot of bugs that popped up just recent and then fix them. And to make things easier and to track things out, I've made a workflow. I'll share the links to all of them at the end of the meetup. But we now have a workflow basically, which let me just go over each one of them. And I made a slide for each one of them. I've made a workflow on GitHub to make it easier to track things out, like what to do next and what's in the progress, and made milestones on the engine. We didn't have it in the past because it's quite a bit of work to plan things out and have them specifically like dated, labeled, and things like that. But now we do. We also the workflow make it easier to track the progress of and the status of the engine, basically. Um, it makes it easier to track what bugs to fix first and the priorities too. But yeah, basically that's now what exists in the engine. Next up is the plugin system, which was quite a bit of work because it took me around 6 designs to make this work, because it was pretty hard to make a design that works with the philosophy of the engine to be extendable and to be easy to use, and also not make it hard, because Rust is not an easy language to make dynamic systems on it, due to all the restrictions that exist in the language, which is really good. And the last design that I came up with was, I was really happy with it, just saying, because whatever came to my mind at first was not as good as the last one, and it's all thanks to the language. I'm just saying that because the language is really good. The last design that I came up was definitely a lot better than the first one, which is something that really pushes a lot of people off when developing in Rust, because they think the language is super hard, so they try to fight with the language. But if you actually go with it and actually listen to what the language wants and the philosophies that it have, it's a really good thing. And your designs will actually come up a lot better than what you had in mind at first. And for now, the plugin system supports two two functions, which is comes with a trait. When you apply the trait, the function two functions basically run um, by the plugin system. The first one is, as you see, is update events, which basically is before any frame or anything. It just takes the raw events of the system and feeds it to this function. It also feeds the window, the objects, the other things that the engine had, but the main focus is for the events, because in this stage there is like no checks for if it's a frame or anything. It's just raw events as soon as they come. This would be good for if you have a lot of different things, like third-party software, for if you want to implement, for example, GUIs or cameras or fly cameras, so to speak, and things like that, which need real-time data for the events. And the second one is the update function, which runs each frame. Uh, by the frame, I mean each frame that runs in the update loop. For those who are not familiar, the Blue Engine have something called an update loop, which is similar to a game loop, where it runs each frame, and then it checks for if everything else has finished in the system and if the frame is ready to be used. And we'll not go into the internals right now, but it's basically each frame is run with the update function if you have plugins. These are done in backgrounds, So the users don't see these APIs themselves, but these can be used very much to make almost anything that I've come across, any plugins that I've made so far. So if there's something that it doesn't work with, feel free to open an issue and I'll redesign the API system. Uh, we can see an example of this plugin system by showing eGUI plugin. The code that you see right now is the user-facing side of the eGUI plugin. And I tried to make it as easy as possible, and there are still some designs to go on it and some iterations to make. For example, the way that it works right now is you get a context by starting basically the eGUI plugin. So these are the initialization functions for the plugin, because it needs to start some things up with the eGUI before it being able to draw. And the second one is you push the plugin as a box to the engine plugins. And that's pretty much it for the initialization of a plugin. You don't have to do anything else. These are done outside of the loop and inside the loop to get the plugin. For example, if you want to do something specific with the plugin that are outside of, for example, the two update loops, you can get it downcasted to the structure that is your plugin, and that's it. Your plugin is now available inside the update loop. You can do whatever you want with it. I'll link two eGUI examples of how it looks like in the full at the end of the meetup. Now let's move on to what have been done with eGUI plugin that we have built with the engine. The most recent news about it is that it supports the end window draws. What that basically means is normally in the Blue Engine you can draw things up with the objects and things like that. The object system is basically making it easier to pack shaders and textures and things like that and manipulate them during the lifetime of your program. But now you can, thanks to the plugin system, you can now use it inside a window of eGUI. So basically you can take whatever graphic you have and now you can plug it into eGUI and have the eGUI handle it. So that's another example of how the plugin system is very flexible and can let you do things that are like normally really hard to think about, but by design it works really good, and however shape or form you want to build it. The another thing that have come in the engine is utilities crate. What it is basically in the past we had a lot of things crammed inside the engine's crate. So, for example, sorry, okay. In the past, we had like cameras, like fly camera, lighting system, animation, and things like that being inside the engine itself, the engine crate, and it's been getting pretty big, the code base for it. So I was thinking of moving it outside of the engine, which is the Blue Engine Utilities. I forgot an E on the engine. But basically, it's a secondary crate where if you want to have utilities with the engine or miscellaneous things, for example, animation system or different types of camera, lighting system, things like that, now they're on a separate crate, and you can just use a flag or example or choose any part of it that you want, basically. Instead of having everything crammed up inside the engine, they're separate. So the engine code base can stay clean without needing to use a lot of flags and things like that, basically. There are some things that haven't been there yet. Basically, the object system isn't there yet. The camera itself isn't there yet. But so far we have moved on the animation, fly camera, light, and things like that. Speaking of animation, we have an animation system now. It's not really a big thing because the animation is really linear, linear manipulation of the animation. So it's not really complex animation graphs or things like that. But so far you can have linearly make keyframes and manipulate objects in the scene with the animation system. It still needs a lot of works to do, and it's also a plugin, but it works so far. And I'm thinking of adding a lot of features to it as the time goes. But for now, it exists now. And speaking of that, we have I've been working a lot to clean up the API because the API was a bit complex at the start, and a lot of people were stuck with how things were done before. So to make it still extendable, the API that user faces are conventional keywords and things like that. For example, on creating a new instance of the engine, you before you had to pass in Windows settings and things like that. Now they're under new config basically, and the new option just chooses the default options itself. It might be a bit inconvenient for some users, but this is to make it a bit cleaner to use. And we also have like separate functions like triangle, and before they were passing on the objects themselves um, as return, but now they don't. And before they also had they also needed the engine itself to be passed as argument, but now it's just specific parts that it uses. Therefore, you can use the functions inside the update loop and things like that without having to deal with lifetimes or borrow checks. The triangle function, how basically the whole definition of the triangle function is on the right side. You can see it's just calling a new object, passing on your name, vertices, indices, and that's pretty much it. And we've also we're working on a type map, but I've decided to not use it because it gave pretty big performance hits on the engine. For those who do not know, type maps basically make it easier to choose your own type arguments basically for your update loop or whatever functions that you use. So how it works is basically if you only want, for example, objects or renderer, but you do not want anything else like camera plugins and stuff, you can just type in the type of the renderer or object, and during the runtime the engine would pass it on to you directly, just that, and not pass on everything else that comes with the update loop. It is a good for convenience, makes it cleaner and just use whatever you need, but the performance hit is pretty big. So for things like a graphics engine that's supposed to be small and run everywhere, it didn't really make much sense because the place that it was going to be used on was the update loop, which the difference between using this and the update loop was just like a semicolon, not semicolon, underscore. So it didn't really make much sense. But the type map crate is still up. Um, I will put a link to it. So if you have a project or a crate that you want to use this type system, it'll be easier to use that, or just look at the code and implement it yourself accordingly. These are these types of systems are pretty available nowadays on Rust. For example, Bivy have it. I think Actix also have it. But yeah, it didn't work with us. And as far as I know, basically, if you have different opinions on it, I'm up for listening about them and redesigning the API however works with the users. And that was a quick rundown of all the updates we had on the Blue Engine since half a year ago. A lot more things have happened, but I have not really had time to push all of the change logs here because a lot of things change. But overall, on the grand scheme of things, those were a few updates on the engine that have happened so far. Thanks for now.
Awesome. So that's super cool. I think one thing that I've kind of learned as I design like the micro jam engine and stuff like that is just like a lot more about how you want to structure something so that it's like ergonomic for people and usable and stuff like that. And so I learned a lot because I'd never tried something like this before. But I'm curious, like on your journey of like going through and implementing the like work on the Blue Engine, like what were some of like the biggest things that you learned from the process?
The biggest things that I've learned is basically I've not used traits very much, which are really good. Traits in the Rust programming language is really powerful if you use it correctly because they're really in depth and they support basically a lot of magical things that are impossible in our language and make it cleaner too. That was the first thing that I've come across that was like really life changing with the engine. And the second thing that I've come across is like people make a lot of mistakes while using your API without knowing. A lot of things that are like natural to you, like this makes sense for me that I've designed it, but for other users that are less experienced and doesn't know much about how your own system works, for them it's very complex. For example, the initialization of the engine, it had an object, the Windows settings basically, where you could add these settings for a window, for example, width and height and title, stuff like that. That doesn't seem a lot to you, but for someone who is newcomer to Rust, which we have a lot in the Blue Engine community, that is a big thing for them to like understand how it works and how to use them at first. Like, what do I put in this structure? Do I have to fill everything up, or do I not? What if I want the default? How the default work? Things like that. And if you change it to just a config function alternative for it, that will like simplify a lot of issues that comes up in your chats. But yeah,
Mhm.
just use names and APIs that are make sense for the user and specifically for them, and use whatever thing that your language supports best for you. For example, traits was in my case.
Yeah, absolutely. That's so true. I think for myself as well, as I was going through it, like sort of just how you start thinking about stuff from a step back, where it's like you have to make functionality works across a lot of different things, and like you really start to dive into traits, and then you start to ask questions. You're like, okay, I do need to share this piece of data across like this or this functionality or whatever. And is there a way I can do this with traits, or is there a pattern that I haven't known about before that now makes sense to me because I'm trying to do this? And so that experience for me has also been like a lot of fun to do. And so I definitely agree.
It is. It is. It is. It's a lot of fun journey to go through all of that. It opens your eyes to a big level.
Yeah, absolutely. All right, perfect. Thank you so much, Alham. I hope we
Thank you
do
for having
catch up
me.
in a few months on more updates.
We will.
Perfect.
See ya.
And we will be cheers. We'll be back in just a few minutes or just a few seconds with Blade. All right. Hello, Quark. So we heard about Blade a little bit ago, and also, yeah. So like, I'm interested to hear what kind of stuff has been on the work. So I'll hand it over to you.
Yes. Hello, friends. Can you hear me fine?
Yes, all good.
Okay. Okay. Good. um, on the Rust Graphic Conference #3, I talked about this new project, Blade. Just gonna run through the slides quickly to show if somebody does not remember what this is about. This is a low overhead, cross-platform, unsafe graphics library that I've been working on, and it's focused on ergonomics. So one of the applications I had in mind for Blade, the main one probably, is ray tracing. And I wanted to share some of the progress I made on this front today with you guys. I can run this example. It's in the main branch of the Blade repo right now, portably on Metal and Vulkan, basically on all the desktop systems. And it has a single shader code that implements it. This is, technically speaking, these two toruses were created programmatically, but they are passed to the library as meshes. And we just cast a ray from the camera and it bounces between them and then flies away to the outside. And based on the how high it flies away, I assign the color. That's it. There is nothing more to it. And this is, of course, it's running real time. It's using hardware ray tracing on Vulkan, and metal performance shaders ray tracing on metal. The shader code itself looks roughly like this. So in the main, we create a ray query object, which is a new thing. Again, the shaders are all in Wixel, the web GPU shading language. So this is a modified Wixel to support ray tracing. We create a ray query object, and we initialize it, and then we proceed to intersections until we find something interesting. At some point, we stop. And once we found something interesting, we can extract some kind of information from the intersection, like what kind of it, how far the ray went, and other things, potentially. Based on this information, we can continue the ray tracing or shade the pixel. This is very much like Vulkan, except that in web GPU shading language, and it's portable to Metal now with the Metal performance shaders. As far as I know, this is the only true cross-platform ray tracing that is out there. I know the DXC library supports ray tracing from HLSL to Vulkan, but this is running on Metal, and I'm not aware of anything that is cross-platform to Metal. And yeah, I'm trying to make this support richer and provide more information from the ray tracing intersection. But the general approach that I put into Naga for supporting this seems to be sound, and I think there is a green light to get something more interesting there. Yeah, that's all. That's a short presentation.
Sorry, I forgot I was muted there. I have a few questions kind of surrounding where this sits in the graphics stack. And so you described that it's like it gives you the ability to be able to target multiple sort of like different backends. And so relative to, as far as I understand with Naga, and my understanding, you can take shaders and then translate them to the different backends. But where does this sit relative to that? Or like, how does that description work, sort of?
Yes, it's the Blade sits on top of the native APIs directly. There is nothing between you and the native APIs other than Blade. It's extremely thin, and the goal is to not even get a hint of any overhead that's happening and allow debugging to be easy if you know how to deal with the native APIs. So this layering structure is very simple. Naga is used for shader translations, just like WebGPU uses Naga, or WGPU uses Naga. And that's because I think Wixel as a shading language is well thought, and there's a large number of good people worked on it, and I want it to succeed. So Blade uses Wixel shaders.
Okay, cool. And I remember at the graphics meetup, you described how the idea behind Blade was that instead of trying to provide everything, it just provides very little. Was that like so?
Yeah.
When you like,
Yeah,
as a layer, a thin layer, it really just tries to do a small amount of things, right?
The idea is that you probably have your own needs, like the guys from the Z editor expressed on Reddit recently. You probably want something very specific, draw a few shapes here and there, have very strict latency requirements, and I don't want to make all of these decisions to you if I can. So you probably just want to take the code base and adjust it to your needs and add like texture formats that you need and things like that. That was the idea. For ray tracing, the support looks more or less complete. There is the API surface consists of a few functions that, like, oh, if you haven't seen how it looks like on the Rust side, you describe the acceleration structure meshes, you build the bottom level acceleration structures with them, and then you describe the top level acceleration structure by basically pointing to those bottom level structures and some transformations. And you build them in a the acceleration structure encoder, which is a subtype of the command encoder. and you use them as objects basically in the API. So from this perspective, this is more or less complete, and you can do a lot with ray tracing in Blade.
Okay, yeah, interesting. And so with Blade, so do you mean that Blade itself is like a relatively complete in like what it's aiming to do?
I mean the API for ray tracing does
Okay.
not have a lot of compromises like I did for, like, there is no vertex buffer things for rendering. It's there because ray tracing itself is very GPU oriented. Like most of the things happen on GPU. In the API, I didn't have to make a lot of compromises, I think.
Okay.
And it's worth reiterating that this is just ray queries. This is not actually ray tracing pipelines. This is ray queries which you can use from any shader stage, although Metal API on Intel only allows it to use from compute. So this example only uses from a compute stage.
All right. Perfect. So yeah, this is super cool to see. I always love hearing stuff from you where you're like, well, this is the first time I think I've seen something like this happen, and so it's always awesome to kind of see the work that you're putting in here. So yeah, thank you so much, Dmitry, and hopefully we see you in a future month to see what else you're working on.
Yep. Thank you.
We'll be back in just a second with 1000 Star. All right. So hello. We are back with 1000 Star, who's going to talk to us a little bit about 8-bit duels. So 1000 Star, I will hand it over to you.
Okay, thank you. Hello, so I'm 1000 Star, and I'm a teenager from Canada, and I've been working on my little game called 8-bit duels for like a couple of months now, and I'll share my progress with you today. And before coming into the Rust programming language about a year ago, I was doing Minecraft plugin development with Java. So I come from that, and I've also done some simple Python when I don't need a specialized language. So yeah, Rust has been very nice for game development. And yeah, I'll show you my game right now. So here I have my terminal. So I'm just gonna run 2 instances of the client because this is a multiplayer turn-based strategy game. And I also need to run the server. So I've got these 2 clients here. Now the UI is very minimal at the moment. I do plan on making it better in the future, but that's not my concern at the moment. So here you can see if I connect the server, this UI is also going to be upgraded in the future. Now, this is the main game loop, which I have here. As you can see, it looks kind of like a small chessboard. So this game is kind of a mix between chess and a game by Supercell called Clash Mini. So basically, there are these like fantasy characters, and they fight each other. And the premise of the game is you place these small troops here, which I don't know if you can see the text because it might be very small, but you place those on the board. And if I place, say, a skeleton here, you can see I can only place it on up to 4 tiles from my side of the board. So let's say I place it here, then you can see it also on the other side. It appears here. And now there's a lot of things that are not explained at the moment, like see here, the blue means, well, obviously that is yours, your troop, and the yellow aura around it means that it's stunned, so it cannot move at the moment. And if I pull up my blog right here, in my latest blog post, I have outlined all of the different characters that I have. At the moment, I only have 4 because I'm waiting on some more art from my friend. So we got the skeleton, the reaper, the kraken, which is kind of like a squid, and also the spider. So each of these has different stats, like the health points, the attack damage, the spirit cost, which I'll get into a bit later, and the abilities. And yeah, so this game, I've been working on it for a couple of months now on my free time, and so development is kind of on and off whenever I feel like it or whenever I have the time, because school is taking a lot of my time. And so if I go back into the game, you can see here I have the two currencies from my from 8-bit duels, which are the pawns and the spirits. The pawns, basically how they work is you start with the game with 6 of them, sorry, and then when you place a troop, then one pawn is taken away from you, and when one of your troop dies, then one pawn gets added back. So this means that basically you can only have limited number of troops on the board at the same time, which is 6. And I do plan on making some troops that maybe have the ability to increase your pawn number. So that's something I can do in the future. Now, the other thing is the spirit count, and that's mostly how you spawn these troops. So the premise behind pawns and spirits is that you use pawns and then infuse them with spirits, and then they become troops. And so these spirits are how you spawn troops. You start with 8 of them, and on each turn you gain 1. And when you place troops, you pay the amount of spirit that is the spirit cost of the troop. So let's say the skeleton here is 2. And then once you defeat an enemy troop, then you gain the amount of spirits equal to that troop's health, that troop's spirit cost divided by 2. Now, another thing I've added are troop abilities. So you can see the skeleton doesn't have any, but the Reaper has the spirit collector ability, which makes it so that it instead of only gaining half the spirits when you defeat an enemy troop with the Reaper, you gain all of the spirits. Now the Kraken attacks 3 times, as you can see here, and the Spider stuns enemies when it attacks them by 1 turn. So if I end this guy's turn and go into here, I can spawn some other troops, and I'll show you basically some of these abilities. Now, if I go here, I can... now, these 2 are stunned, so if I click on this skeleton, then I can move it with all of the blue circles. So let's say I move it here, and then I can attack either one of those. So I can attack, say, the Spider, and then here I have the Kraken, which can attack 3 times. So you can see this. It can attack 3 times, and then it can no longer attack. And I also got the Spider, which has the stun ability, but now the skeleton died, so the Spider is taking its place. So that's pretty much it for the game loop. Now, how you win is you get to the end of the board using one of your troops. So I can show that here. Now, it doesn't end exactly on the turn you get there, because you need to be able to move to end the game. And so if I see here, I have the little win button, and so that ends the game. And so these are visual bugs here that I need to fix. So that's pretty much it for the gameplay loop. Now, the other thing is when I start the game, when I start the game for local development, you need to use the this flag, like the --dev flag at the end of cargo run, so that it's because of the library for settings I use. If 2 instances run at the same time, they're going to crash. So if like running the game locally with 2 instances, you need to run this option. So if I remove this option, then you can see now the settings work. And so I've got this username here. The address for the server, and then debug mode, which is going to come later on. And this is mostly coming later on, except for the server address. And the username is for something that I will show right now. Is if I go into here, and then I can run. The important thing to keep in mind is when running locally, at least one of the 2 instances need to use --dev, and that instance won't be able to use. Oh, I think that just crashed because this server port wasn't the right one. Yes, so I need to fix that later on too. But yes, when I run 2 instances here, you can see the other thing that I didn't mention is the chat here, which you probably have seen. And it's a very simple chat at the moment, but I do plan on adding usernames. As you can see here, it just says player, but I do want it to use the usernames from these settings. So that's pretty much it for the game I've been working on in the last couple of months. I post a blog post occasionally, like maybe once a month or once every 2 months. At the moment, it's been a while since I haven't posted anything. So that's pretty much it for 8-Bit Duels, my game.
That's super cool. So a few things I'm curious about. So I think I was taking a look at your repository just a second ago. Then it looks like you're working in Bevy, but I'm curious
yeah.
like what your experience has been with Bevy, as well as like what else you might be using your tech stack.
Yeah, so I've been using Bevy for the entirety of my Rust journey. So when I was looking back when I was starting with Rust, I was like, well, what kind of engine can I use? And I saw Amethyst was there at the moment, but then that project kind of got like killed for Bevy or archived, say, and then yeah, so Bevy I find is very nice for the ECS, which is something that I've never worked on before using Bevy. Well, before I did do game development a little bit in Unity with C#, and though that model was kind of like not optimal for me. I really like how the ECS works because you can have a global data where in Unity I found it was really hard because all of the like data is contained within game with objects, and so unlike ECS, you don't have global resources, which are very nice to have. And so on the tech stack, other than that, I think I have Igui for the UI, and then that's pretty much it. Apart from maybe some small libraries, I think I was toying around with Kayak UI, which is another UI library. But I think I think I'm just gonna stick with Igui for now.
Mm-hmm. And then just out of curiosity, for like the networking side of things, how does like the client and server work?
It's basically the standard library TCP. So that's how it works. And I've got in the common directory, that's like kind of like the shared API between the two. It just has like in the messages, there's like the packet definitions and how they work.
Okay, yeah. So this is like the exact same way that I do networking, and I love it so much how you can just throw everything in an enum and you're good to go. It's like such a clean way, and also I call mine the common crate as well. Like this is like the exact same architecture I use, and so it's pretty cool.
Yeah, and also I have like the troop definitions, which are here. I have the troop definitions, which aren't like super clean, but they're just like structs.
Yeah, so you can kind of like store them inside of here and then make changes to design through here. One thing that we use for Valorant actually is RON files, and so this is how we do like a lot of our game design. And so it's similar to this, but then stored in a different file, and then you load it in. And so I mean, this type of way of doing it is like pretty cool for design. I think it was also cool hearing about like some of the considerations you're putting into design and like how you're planning it out as a game, not just as like a technology you're building, sort of. And so that's pretty cool.
I think when I started the project, one of the like very poor decisions I made was like separating completely the client and the server. So I had like this file on both crates. And so one user pointed it out to me in the Discord, and so that was very, very helpful. And the other thing is I was like making the packets as well. They're sent as JSON. Then I use a Serde. That was the other thing about my tech stack. I use Serde to serialize and deserialize the packets. But I was sending like raw JSON that I made myself, and so that was very like not useful because I had to extract the values from the packets like directly, and then that was not very.
So instead of like deserializing it, like with Serde, you were using your own custom JSON.
So I'm learning a lot of things along the road, and it's very useful.
Yeah, exactly. And I think a lot of the time when it comes to these kind of things, it's like you have to have the motivation first to learn it. Like you do it wrong so that you understand when there's like a better way of doing it, that like what the actual benefit is from that. And so that's super cool to hear about that progress there. This is awesome. I'm really happy to see this. And also, it was super cool to hear you're also Canadian. That makes two of us. And so I think I'm really excited to hear more about this in the future. If you put out more blog posts, I'll definitely be reading them from now on. It's pretty cool that you have 8 out that I can like take a look at here.
Okay. Well, that's cool. Thank you very much.
Absolutely.
The development is kind of like on and off because like school is taking so much time and the projects are like so long. So It depends.
Yeah.
And some months I have a lot of time, and some months I don't. So it's kind of like
Yeah.
not enough. Yeah.
That's very fair. That's very fair.
And yeah, the latest thing I've been working on is like the animations. So like when I showed like the troops going to and from like when they attack, so that was not there before, and now it's a lot clearer when you're playing like what your opponent has played. So that's something that I just made. As you can see, like the latest commit was like 5 days ago when I made those. The start anims commit, which is like on the client.
Yeah, I feel that too sometimes. On the like, I have a lot of projects. I'm really good at like starting a project every week, kind of thing, and so they're all private on my GitHub right now. But someday I'll make them public. And
yeah, if I finish this game, it's pretty much gonna be the second game that I like finished completely, because all of the others I haven't completed.
Yeah,
and the other one was like a golf game that I made in 2 days, so not very interesting.
Well, but at the same time, sometimes prototypes that only take 2 days turn out to be like the best ones you make, and that's what I find sometimes.
Yeah.
All right. Perfect. Well, thank you so much, Thousand Star, for showing this off. It was really cool, kind of seeing behind the scenes on this and hearing how you've been working on it. So I hope you see you in the future.
Okay. Well, thank you for having me.
Absolutely. Cheers. Right. Hello. We are back with Kevin, who's going to give us this month's update on Graphite. I'll hand it over to you.
Thanks for having me this month again. So, to anyone who's just tuning in for the first time and you just need an overview of what Graphite is, we're basically aiming to make the ultimate 2D graphics editor for any kind of thing, ranging from game development to graphic design to photo editing, basically anything in the creative arts that you would be using for something that you need 2D tools for. The idea is to have a node graph that actually powers the entire backend, but still provide a front end, sort of like the user experience, the interface that you're used to in something like Photoshop or GIMP, which basically provides you a way of working with tools to modify your image. But then those tools will end up actually modifying a node graph for you, encoding the image in a more data-oriented way instead of a pixel-oriented way. Here is sort of our first update. We do have a few UI changes to this mockup. So we're actually getting relatively close now in our roadmap towards reaching this mockup, but what you're seeing here is a mockup. This is what we're designing. We have a new button in the left here. That is the node graph button. So you would click that to cause it to overlay the node graph on top, and then you can see it becomes active. So before and then after. And this node graph looks somewhat similar to what you might have seen before, but we've made some relatively important changes that have made it, I think, well, first of all, it looks nicer. We're sort of leaning into this sort of glass aesthetic where it diffuses the color beneath it by blurring the background. But we're also just making it a little bit easier to view different nodes without being distracted by how the nodes transit data between each other. And then we're also making it so now we have the thumbnails displaying the value of the data directly in line. So you can see you have the image, and then you can preview that image by seeing what data is actually flowing to the next node. And here's the shape. You can see that we have some vector data. That's what blue represents. Blue is the color for vector data, and it flows, and you can see a preview of what it looks like into the mask layer. So that vector shape is being automatically coerced into a raster type to be fed in as a mask. Then you can see it travels through, and you end up transforming it. Then you apply a motion blur to it, and finally this becomes your layer. So what you're seeing here is basically a layer, and a layer is something you give it a name. It kind of acts like a folder in your structure, in your layer tree. But it's composed of nodes. So the nodes build the data that enters and becomes the layer. And then layers get stacked on top of each other vertically. So the flying jet is going to end up being put on top of the Death Valley backdrop. And then finally, that Death Valley backdrop is provided by two other layers. So basically, this is describing a folder where this layer is acting as a folder where it contains these two. And each of these two are individually composed of something. But here's where you can see the really powerful part about the node graph. This backdrop here is actually an image that's imported, but it's providing its data to both layers. And that's something you definitely could not do in a traditional layer-based editor, because you couldn't import something once and then use it in two separate layers to feed the data. So in this case, we have the image being used directly for the landscape, but we also have it being used to feed in the input for a magic wand selection. So the magic wand selection lets you pick a certain color, and in this case, we are picking the blue.
We're getting some interesting graphical bugs. I'm going to check on the YouTube as well, but it's like stuttering a little bit with the mouse. You might need to reshare your screen here.
Okay. It's possible my mouse is just disappearing. Is that the only problem?
It's not disappearing. It's just appearing a lot of times everywhere all at once.
Oh, weird. Maybe I should restart the screen share.
It is quite curious.
Is that possibly better?
Let me take a look here. I don't think so. So what it does is it like grabs your cursor every few seconds and then like leaves it at that location.
Weird.
We'll keep going for now and then see how it is.
If it's terribly distracting, we could try and resolve it. Otherwise, we might just live with it.
I think live with is fine.
Okay. But anyways, that's mostly an overview of the node graph, and the layer tree on the right is actually just the same thing, all the exact same data, but it's represented in more of a traditional classic layer panel style. So when you don't have the layer panel open, so if you click on this open the overlay node graph button, and you end up back in your actual canvas view, then you can see that you can just modify the layers directly, and that's with a slightly modified design, but it's relatively similar to previous months that we've shown. But that hopefully goes into a little bit more detail, because we don't normally talk in detail about how this works. So basically, you get to use something that you're sort of used to already in existing editors like GIMP and Photoshop, but then you can also take sort of a Houdini or Blender geometry nodes or Blender shading nodes, or like a Nuke style compositing approach to modifying your documents, even though it also works with the layer panel directly. And that's something that's pretty novel. I don't think there's anyone else doing a layer panel and a node graph that represent the same thing. Anyways, with that overview provided, which also includes some of the UI changes that we've worked on in the past couple months, and especially some polishing changes to the UI in the last month, now we can talk about some of the changes from this past month, so in the actual code. So the first big thing is that the journey in migrating from our front-end framework of Vue to Svelte has completed. This was something that I had started a few months ago, but we ended up having a bunch of regressions that sort of made it impossible to actually fully finish the port, which had a problem where it basically meant we had two front ends. We had the actual production front end, and we had a buggy one that should have been identical but had some bugs. And there are still a few bugs, but we fixed almost all of them. And the ones that still exist are apparently not important enough that we have not noticed them yet. However, if you as a viewer of this, and hopefully a fan of Graphite, are interested in helping us find more of these regressions, please visit issue 1040 on the Graphite repository. And there is a link to provide a direct comparison to the two different builds. One is running Vue and one is running Svelte without any other changes between the two. And if you can find bugs in the Svelte version and then make sure that they don't also exist in the Vue version, please, please, please help out by writing a comment describing those regressions that you find, since we want to fix every single one of them, but we don't currently know what all of them are. So that's basically just digging into every single little feature and seeing if anything breaks. Anyway, so with that completed, I will be showing off now the Svelte version, except nothing looks any different. It looks identical, so there's nothing really to point out. But I will then move on to the next one, which is saying that we completed some node graph engineering work on the node graph type checking. So what this basically means is now in the node graph, you can plug data types, plug different nodes which have different data types into each other. And if they're not compatible, they will actually tell you that it's not compatible and reject the attempt to connect it, rather than previously, which did not succeed nearly as gracefully. And this, of course, allows us to do a number of other things now that it's possible to know what data types are compatible with which things. So we can, for example, allow you to delete a node, so this will be something we work on soon, deleting a node, and if the input and output data types are actually identical, we end up just reconnecting the two to each other to pretend that the thing that was connected before the node and after the node are now actually connected, pretending like you never had that node in the first place. So that will help allow you to delete something without having to reconnect it. We now have, so I also can't really show the node graph type checking very easily, but because it just works better now. But we do have another feature, which is kind of cool. This is a configurable choice between panning and zooming when you use the scroll wheel. So some people prefer to scroll with the scroll wheel moving up and down like it's a web page, whereas other people, maybe if you're using Blender, you prefer to have the scroll wheel actually zoom in. So now that I enable that in the preferences, you can see that by default we end up zooming, and now if you hold the shift key while you're scrolling, that actually becomes a proper vertical scroll, and then also the control key would be horizontal, just like normal. But then if you disable that, we're back to now vertical scrolling, and now you hold the control key if you want to zoom. So that provides you the way to work with whatever you're familiar with. And then additionally, we have the same thing in the node panel as well, in the node graph. So you can either middle click to pan, or you can go up and down with a scroll wheel, or if you enable zoom with scroll, you end up being able to pan around like that, to zoom around like that. And then of course, as before, hold shift to go vertically and control to go horizontally. And then of course, simple as opening up the editor preferences, you can either get that from file preferences or the command or control comma key. And that is a nice way to start having more preferences for things that people have, well, preferences for. So yes, the next item is we do have some general UX improvements to vector editing. So with a path tool selected, I'm actually going to delete this thing now here. So I can go ahead and let's just say I make a shape. Let's make it a new color. Let's go with that. So now I can select several different anchor points. And then if I decided, actually I want all of them selected, I just select in the middle. Or I can deselect all of them by selecting out of it. So I can click between them now. And the first time you click, all of them get selected. And if you click on any subsequent anchor point, it replaces the selection. So this is in line with more of your general expectations for when you're selecting things, like even if you're just selecting files in a file explorer. That is more how you expect things to work, where if you click once, you deselect everything else. And then if you click the entire shape, it selects all of them by default, so that way you can say, hey, I want all of them except that one selected, so you're going to shift click to deselect just that one. And then of course you can drag around the point. Now this I think previously did not work as well, where you could not drag around the selection and edit through those means. So that is one simple improvement. We also now have the pen tool. So the pen tool allows you to draw shapes, but what we now have is the ability to hold down control to lock the angle. So now wherever I move my mouse, I'm locking the angle to how I already started. So I can move it here and now hold control and lock the angle. So this allows you to be more precise. You can say, I want to go in this direction to this point, but then I want to extend beyond that point. So it's a very simple way to control the direction. And I don't think there's any other editors that I'm aware of that really let you do that with a pen tool. So that's helpful. And then finally, one really cool feature here is the ability to select nested layers in a more intuitive way. So you get to choose now if you want to be in what we previously had as the default, which is shallow select mode. What this basically means is, the default has been deep select mode. And what this means is, even though this triangle here is deeply held within a bunch of folders, we're selecting the deepest item. So we're always going to select the actual shape or the actual layer directly, even if it's deep inside of a folder. So whatever you click on is just what gets selected. But now if you go to shallow select mode, you can click on the triangle, and then you actually end up selecting the shallowest item. So that's the upmost parent folder. And then to go inside of that, you just double click. And as long as you're double clicking on a shape that is within your selection, you end up actually going down one layer. And now we're in this folder, which holds all the shapes except for the outermost shape. Now if I just keep double clicking, I get closer and closer. Now I'm selecting the folder that contains the triangle, and I double click one more time, and I end up having the triangle itself selected. And now I can click on, for example, the this outer shape, and because it is contained as a parent of because it's contained within a parent folder, we end up selecting the shape directly. But now we have to go and double click again to get down. So this provides much more control, especially if you're doing something with a lot of nesting. For example, you might be designing a UI and you have a bunch of different rectangles representing different parts of your UI. You want to be able to control which parts you're selecting, so you could, for example, drag an entire panel around within the UI you might be designing without having to go through and select every single one of them. You just select sort of that general region, that whole panel, rather than all the shapes that make up the panel. So that makes it much more convenient to choose if you want shallow select or if you want the default, which is deep select, and basically that changes nothing. Additionally, in shallow select mode, if I want to not have to double click a bunch of times to get to here, you can basically just hold the control key, and that allows you to do a deep selection. So you simply want to say, I want to select the deepest item, just hold control, and even though you're in shallow select mode, it will select the deepest. And then you could even, for example, add that to your selection. So I want to have this one, I want to have this artwork selected, and I want to also add it. I just control shift select, and that will add it to the selection. So that makes it much easier to generally manipulate layers that are in the nesting structure. And that concludes the changes for this month. And for the following month, for this upcoming month, we have decided to delay the announcement for Alpha Milestone 2 until we make a few more readiness goals, essentially. We want to fully switch over to the node-based panel, which replaces the existing layer panel with a node system. Sort of as I talked about, where we have the dual node graph and layer panel in the earlier part when I showed the mockup. We want to implement all of those concepts before we end up releasing, and hopefully we can get that done in the next couple of months. So yeah, if you want to get involved, I did previously mention the easiest way to get involved would be helping us to QA test and check for regressions between these two features. Just check out issue 1040. And besides that, please go ahead and get involved by, well, first of all, just trying out the editor. And you can do that at editor.graphite.rs. And you can also visit us on the website, which is graphite.rs. And also, please join our Discord. We just have a friendly community of just people who use the editor and are interested in the project. So feel free to just hop on and say hi, or even just hop on and don't say hi and just lurk. Any of that's good. So you can find the invite link at discord.graphite.rs. And then we have a lot of issues that are labeled as beginner friendly. They're listed as good first issue on GitHub. And even some really small issues that are specifically curated just for beginners. So if you do want to pick that up, we're very happy to provide you some guidance and make it a friendly place to get started with open source. So yeah, thank you for watching.
All right, perfect. Thank you so much, Kevin. We have a few questions in chat that I'm curious about. One of them is there a CLI for Graphite, either now or planned?
There is definitely one planned, yes. The idea is we would like to be able to provide the ability to edit your documents in sort of a programmatic way. This is something that we have architected the entire application for, with the intention of making it so you can edit the documents, either in a headless mode with a CLI or with an API, and not just the documents themselves, but you can also render them. So you could pre-create documents, like probably in the editor, because that's the easiest way to do it. But of course, you could modify them or create them from scratch with a CLI or an API. And that way you can programmatically have a document, change it, and then render it on the fly. And the idea is we even want to provide a runtime that you could embed in. For example, you could embed it in your game. And that way you could run the Graphite documents and render them in your game and use them as textures. So you could either do that for like UI design. So you might have a character's health bar, and you would feed in a parameter which is the percentage of the player's health, and maybe any abilities or their mana or different other traits that they have. Feed those in as data, and then that would procedurally render your UI for that purpose. Or you could even have actual like model textures. So as the player's walking through mud over time, that mud starts accumulating on their clothes and on their weapons and on their gear. We could re-render the texture every so often and replace that with the existing texture that's applied to the models to provide something more contextual to where the user is, what their environment is. If they're walking through mud, if they're walking through snow, you might accumulate different procedural effects on your models and textures for that. So that's the idea, is to have a very modular way of designing the graphite architecture so that you can use it in many different contexts outside of just the editor itself. And then the idea is even that we have the editor itself is somewhat generic or somewhat modular by comparison to our front end. So you, in the future, could implement your own graphite editor in, for example, I think we've talked about this as a, sort of a general idea, but someday in the future, Bevy could implement their own texture editor, and they could use the graphite editor, but implement their own front end and their own UI for it, and be able to pick specifically the features they want to focus on, but be able to still implement that using the graphite backend. So it would still use the graphite document format, and it would still use the render engine and the tool system, but you could basically use which tools you want and apply that as necessary, or basically as the way that fits your needs.
Yeah, okay. So I'll be honest, when that question was asked, I didn't really understand what it could mean, but some of these use cases you presented are so powerful that I've never thought of before. This idea that when I'm in a game engine, when I'm editing stuff, I click on the color bar and I do the color picker or something like that. But if that could just be a gateway to Graphite's backend, and I could pull up the Graphite node Graphite if I wanted the front end, or I could do stuff in whatever way so that I can really dive so much deeper. Like that is an idea I've never considered before, but that's so powerful. And then also I didn't believe, so when you said at first you could load the texture in, add some like mud to someone who's like running through mud or something like that. I'm like, that doesn't, in my mind, that doesn't make any sense. Like, why would you want to have like all of Photoshop there? But I'm like, wait a second, Graphite's pretty modular, it's probably pretty small. Would it be something that you could just ship with your game? Like, is that sort of the idea?
That's what I was describing. Yes, you would would ship the runtime environment, so that essentially is the code that does the rendering, and then you ship your documents, and these documents describe how your texture looks. So your character's gear or whatever, and then because these are really small, they would render. The documents themselves are just a description of a node graph. They're not a bunch of pixels, so it's actually going to take up less space by comparison to a texture. And as long as you have the budget in your frame rates, or either your frame rates or your loading to run and render this graph ahead of time, or at runtime, if you can spare the if you can do it slowly, if you don't have to render every single texture in your entire game at once, except when you're maybe loading the game at the beginning. Then I think you can probably spare the frames just to re-render, just your character's texture. But basically, in that case, it would only be, a few kilobytes, but you'd render the entire texture on based upon the current context. So if it's snowing, if it's muddy, if the character just walked inside of water and washed off the mud, you get to re-render that at runtime by simply shipping our library, which would be the renderer, plus your own actual art files, the actual art itself, and those will be really small, like several kilobyte sized files, instead of
that's so
to
crazy
large
to me.
Textures.
I've never thought about this dynamic side of like art in games, and so that would be super cool. Path to kind of see stuff.
This is something that Substance Designer does. They do have a runtime that some games do ship, but I guess it's not that popular because typically game developers do find it easier just to export the texture ahead of time. But I do think, I think Metro Exodus does that. That game does it where you, over time, as you're walking through the environment, your weapons do end up getting muddier and more beat up. So basically it's that idea, but in an open source and hopefully more nicely implemented manner.
If you approach it from the perspective of this is what the outcome is, and so we're going to build the ergonomics for it, instead of having like, we've made this big photo application and how are we going to expose a small part of it to a game or something.
I mean, that was the very first month we even started working on this code. We first started thinking, what are our goals here for how people will use this in a portable manner, and that's how we ended up building the architecture to support these use cases.
Okay, awesome. Now, one more question we have here, and this is a question that I'm particularly interested about because we often answer the same question about Valoran, but what features are needed before Graphite can become the default 2D editor for general 2D graphics? And I think the thing I want to add on here is it's very difficult to know when you would release a 1.0 of something or when something is complete. But in your mind, what are the things that you want to see?
Yeah. Actually, let me answer that question with a with a roadmap.
I think Zola died there.
Oh, I'm in the wrong folder. So we do have a roadmap here.
Okay.
We
Wait, is this
are
roadmap?
actually,
Is it out yet?
is it working?
Yes. Sorry. Is the roadmap out yet, or is it still like?
We're still working on this update to the website.
Okay.
The small change is that I think we're actually going to move Alpha Milestone 2, which is the upcoming release here, down to, I think, here. One more.
Okay.
So, one more beyond that too. So we actually want to complete these features before we end up switching to Alpha Milestone 2, which will be the next year or so of development. We want to work on adding a brush tool, web GPU in supported browsers, so that will provide GPU acceleration, vertical compositing of nodes. So that's the idea where you saw that everything is basically a layer. And everything is either a node or those nodes that feed into a layer and allow you to composite them on top of each other by stacking them. The node-based layer tree, which means replacing the existing layer tree, which is sort of a stopgap measure to provide some sort of layers that we can use before we had the full node graph built. This will be representing the graph data structure in that layer panel. And then graph-based documents basically means that we will have switched away from those legacy layers and we'll have an entire single document that describes, a single graph that describes your entire document, rather than having a bunch of separate layers with separate graphs in each layer, which is sort of our transitional phase. We're trying to get from layers to documents. And then we're going to be finally finishing the infrastructure needed to deploy a Tari app. So providing people the ability to download and update Graphite through the web. We'll just have a download button on the website. And then finally, custom subgraph document nodes, which basically means you can make a graph and then make it reusable. So you just make some procedural thing, perhaps, that does something, and then just encapsulate that in a graph, and then you can reuse that as a node. So that will be sort of our roadmap in the next couple months. Hopefully, that's a little optimistic.
Yeah.
But we want to complete those because that will be like the point at which Graphite has fully become a graph-based, like a node graph-based editor, as opposed to our current approach, which is we had to use nodes in the short term because we didn't have a node graph, and now we're doing all the node graph engineering work to fully switch this over. And then Alpha Milestone 2, sort of just very briefly, it's going to be all the sort of things needed to make it useful as an editor. So this gets back to answering the original question. This is just going to be a lot of making the node graph more useful, so you can sort of provide metadata that flows along with the rest of your data. So you could give it like color information, and then a downstream node ends up using that color information when it ends up turning points into shapes or something. Procedural vector data is going to replace our existing vector data format with something that is much more conducive to use with vector stuff. Finally, importing SVG, because we really need to import SVG, but we just haven't built a parser for it yet because it's actually a decent amount of work. Then we're going to be switching over to the Velo renderer. Instead of using SVG for our render engine, we'll be switching over to Velo. Looking forward to getting that done because that's going to hopefully improve performance considerably. And then select mode and masking, allowing you to basically use the existing tools as sort of a lasso selection or as a marquee selection. You can use the pen tool in place of the polygonal lasso tool that you might be familiar with in Photoshop. You can use just the rectangle tool instead of the rectangle marquee tool. Basically, you use the existing tools to make a mask, but you do that in a way that still shows you the marching ants, and those marching ants then become used as your selection when you actually change other things. Just sort of quickly going over the rest of these without having to talk about each one individually, some refactoring. This would be the concept of a resolution agnostic renderer where you can zoom in forever and it just keeps re-rendering everything at the higher resolution. A better snapping system just to help improve the UX for snapping and doing more pixel perfect work. And then also having Rust that runs on a server and can compile specific changes. So if you're working on if you want to make your own custom node by writing a Rust shader, you write the shader using
Oh my
Rust,
gosh.
and it becomes CPU or GPU compiled.
Yeah, and
when
it's
I
just
say
serverless
shader, I
at that
mean,
point.
yeah. So we do have to provide a compiler. So we have to be able to do something like the Rust sandbox, where it has a web-based compiler. We need that infrastructure. Or if you're running it locally and you have Rust installed on your environment, then you just do it locally. Then we'll have a custom code editor, so you can write your own code directly in the editor using like the VS Code Monaco editor that we build right into the web page. And then a document history system, so you can actually sort of have like a Git-like history tree of your changes. And then finally, culminating in a stable document format, so we don't keep breaking your documents every single time we make updates every day. Sorry that we do that, but we don't really have a good way of doing it until we can properly design a backwards and forwards compatible document format. If anyone, by the way, has any expertise in designing file formats that are meant to be robust, we need to consult with people who have experience with that, because we have never done that before. So that's something we do need help with.
I might need to cut us off here just in the effort of time.
Yes.
But yeah, this
I'm
is
just
super
gonna
cool to
scroll down,
see.
so anyone who wants to see the rest of the roadmap here, I'm not going to go through each one of them because this would take a really long time.
Yeah, there's a lot. Okay, I
1.0
love this like list of features. This is a lot of really cool stuff.
My power was out for a week, so I just kind of went and drew a whole bunch of icons.
I love the icons. Like, yeah, they're very authentic. It's super cool.
And then, yeah, we'll eventually get to the 1.0 release, and then after that, here's just a quick taste of things that might come after it, like animation. And then lots of things will keep coming forever.
Yeah, awesome. Great. Well, Kevin, thank you so much for showing off Graphite again this month. I think there's a lot of hype in the chat for like a lot of the stuff that you discussed, as well as some pictures of like the cursors doing some stuff, and so that's gonna be fun to look at later.
I will have to watch the YouTube stream after this and see what it looks like.
It was pretty cool. All right. So I guess we will see you next month.
Okay, thanks.
All right. So just to finish off, oops, where do I have my screen here? Just to finish off today's meetup. Okay, so I promised the video earlier. I'm going to play the video now. I turned down the audio, so I think it shouldn't be too loud this time. This is just a little demo of the stuff that we had from the Rust Nation micro jam. And so here, I'll play it. All right, so yeah, it was really cool, and so as we saw, there's like quite a few different takes on what you can do with the game design of what we put together. But the interesting thing is that we got everybody to start with the demo of Pong, and then told them to go off and do what they liked. And so the engine that we put together allowed you to draw circles and squares and anything else that you want to a frame buffer. And then people went and developed like their different physics or their different interactions or their different mechanics, and it was really cool to see what people put together in such a short amount of time that day. And so. Yeah, that jam was a ton of fun. I think I put the video up on my my Twitter if anybody wants to go check that out. So with that being said, I also want to talk a little bit about Valoran. I don't want to do like a super full run through of like booting up the game and going through some stuff, but I do want to talk a little bit about some of the activity we've been seeing on the main game server over the last few. Well, actually, how long has it been? If I go to like last 30 days. Okay, so we see like right here, we've had a spike in the number of players playing Valorant. And so this is like the daily, well, like over the day, like this day we hit like a peak of 185 players online, then 220. And this is like relatively normal is what we've been seeing recently. But what happened here is that we've started hitting spikes of like 300, 280, 300, almost 350. Okay, well, like the peak here is like 380 something. And this is like been remaining consistent. It might be like dropping off a little bit, but I haven't been tracking this fully, and so I don't know the exact story. But I did hear in like our I've been chat on Valorant, we were talking about how people are making TikTok videos about Valorant, and so it's super interesting because there's like videos that people are making that oh no, it wants me to do stuff. Okay, okay, I'm a robot apparently. I don't think I can move that, but people are making videos. They're getting a lot of views. And it's pretty interesting to kind of see the influx of players from that. And so I think it is also awesome because we get like reinvigorated as devs. We see like a lot of people are playing it, enjoying it, and then there's like some really cool development going on from that. And it also brings a lot of new people to our community. And so now that being said, though, whenever this type of thing happens, we always have to go and look at like what's happening on the server side of things. And so we've started capping the server to, I think either 300 or 350, just because after that point, it's cool that we can hit 400, but it's not playable. Like it's just too many people online. And so I think people will go back, like our like Valorant devs will go back in, take a look at what has been sort of like, what could be optimized, or like what the types of things could be done to fit stuff a little bit better. But that being said, like the main metric that we care about to see how badly stuff is running is like the amount of time a total tick takes. And so like right now we're looking at like over 100 milliseconds for ticks on average from the looks of it. And that means that you'd only get 10 server ticks a second, and we're looking for 30 server ticks a second. And so we need quite a lot more to get all of that working. But that being said, that's just like a little small update on Valorant stuff. It's always kind of fun seeing influxes. The last big influx we had was because a lot of Spanish speaking communities on Twitch were playing the game, and so a lot of people found it through there. But that being said, maybe we'll have some cool updates next month on how the server stuff is going. I don't know if, right now we don't have a good way to see like how many players are playing across every server that is like registered with Valorant. And what I mean by that is when it comes to like people who are hosting their own custom servers, we have like different server providers that we like kind of like know that they're running servers and stuff like that, but we don't get a number from them right now on how many players they have online at one time. So that would be really cool to kind of see just like the ebb and flow of Valorant players across all servers. But anyways, that is the end of today's Rust Gamedev Meetup. So again, as always, check out this month's newsletter. If you have cool stuff that you're working on, please add it to next month's newsletter. I've been getting GitHub issue. Let me see if I can find it quickly. Meetup. Okay, well, I don't have it up right now, but I try to make GitHub issues where we can go through and set up like if you want to participate in these meetups, if you want to show something off, it can be as little as just a 5-minute demo. We'll chat a little bit, or it could be like a little bit of a longer form thing, whatever you like. So I really love seeing new people coming and showing stuff off. So it's always great to have that happen. But with that being said, I'm going to move over to the Game Development in Rust Discord to chat a little bit. If you're free and you want to hang out, feel free to stop by. But with that, we will see you next month.